Students and friends, welcome to my YouTube channel. My YouTube channel, Dr. Ashok G Max Solution. So today, what I'm going to discuss, we'll find the support reaction at given point A. These questions, like these questions, will be the GATE exams will be very important. So sometimes they'll ask find the VA. The given diagram will find the VA choice will be there. So you have to know all the basic, all the fundamentals. Here, what you are seeing, one lead is fixed is there. Point A fixed. 10 kilonewton one point load, then C in between C to D, 5 kilonewton UDL, uniformly distributing load given. Then at point E, the given moment, that moment is clockwise moment given. And E to F, the given uniformly varying load, UVL, uniformly varying load, and that given it is in reverse direction. They may give up on the beam or down. So what you have to technique or what you have to concept you have to keep here. First we'll draw this given diagram, we'll draw the load diagram, all the basic concept. Once we know the load diagram, then we can find the complete reactions at point A. Then whatever question they will ask, either MA, BA, HA, whatever they will ask, we can answer. So we'll start now. So first we draw the load diagram. Fixed end will be there, the three reactions will be there. Hinge will be there, horizontal and vertical will be there. Roller support will be there, means only vertical vertical reactions will be there. If fixed end will be there, so this is vertical, this is horizontal, and one moment will be there. Three reactions will act. This you should know. Hinge means two reactions, vertical and horizontal. Roller only vertical reaction. Fixed in horizontal, vertical and moment. Three reactions will act. This first basic concept. Now UDL. If UDL will be there, how we'll draw the load diagram? So suppose this is W kilonewton per meter. That means unit length. Suppose this is length is L. If you draw the load diagram, load will act in the middle, because if you due to this UDL load, deflections will come this way. So maximum deflections will be in middle. So load will act into middle. So W into L. This is L is length, kilonewton per meter into meter, kilonewton. So load is WL, and length will be 1 by L by 2. This also L by 2. So if we will find the moment, once we will find the moment, it will be easy. Once we are converting into point load, we'll calculate the moment. It will be very easy. Suppose this point A and B. Suppose we will take moment about A. Moment is nothing but force into perpendicular distance. So what is force? Load WL. And what is perpendicular distance? Into L by 2. So this way we can take the moment. So this concept you should know. Bending, UDL will be there, deflections will be in middle. So that means load will act in the middle. If we will take the moment about A, force into perpendicular distance L by 2. This way we can do. Then now UVL will be there. That also concept you learn here. Suppose this UVL will be there. Triangle. UVL also known as triangular load. Okay, this way I am explaining first. UVL will be triangular load. Either triangle will be like this, or triangle will be inverted, whatever. So suppose this is the triangle. This is length is B. This is length is H. How to find the load? Here UDL load also you can say rectangular load, length into breadth. Length into breadth will be the load, because this is rectangular load. So length into breadth. This is triangular load. Now what is load equal to 1 by 2 into base into height. This will be the load. We'll convert this into load. Then here load is acting middle point. Where will be the load will act? Suppose this is B distance. Where will the load will act? That concept is very essential to find the load diagram. So suppose this is the UVL, either downward or upward, whatever. So this is the load first we got. 1 by 2 into B into H. Now where this if you draw the point load, where actually this load will act. So now you see here one technique is that if lower sections and this bigger section, center of gravity point lies in between somewhere here, then what is this distance and what is this distance? We have to find out. So we know this is 2h by 3, 2b by b, there no base, 2b by 3 from this side, b by 3. That means what is meaning of this? From this side it will see, the b by 2 distance. If this side will see, it will be 2b by 3 distance will reach. B side, suppose top level will see na 2h by 3 distance and bottom we will go na h by 3 distance. That means this also, this length will be h by 3. This length will be 2h by 3. From horizontal, this length will be 2 by 3. How to remember? See, one example I'll give now. Suppose this is 6 meter you take. So now calculation is 6 meter. This is 4. Suppose we are going this way. Going na, somewhere here will be there. So this distance will come. So substitute here 2 into 6 by 3. So how much? 4 meter came. From this side, what is? Here 2h by 3. Here h 2. Suppose this is b na 2b by 3. Here b by 3. So b by 3 na 6 by 3. How much is coming? 2. So this distance is 2. This distance is 4. So that means, suppose sometimes you are writing, you have to remember either 2 by 3, b by 3. This 2 will be there. If this 2 you will add, b by 3, b by 2 is b by 3. Where I wrote anywhere? b by 3. 2h by 3, 2h by 3, h by 3 for the, okay, for h by 3 here from bottom here, b by 3 from this side. So, okay, so 2b by 3 plus b by 3, how much is coming? 3b. So finally b is coming this length. That means either lower cross section 2b by 3, bigger cross sections b by 3. That you have to remember. But suppose you forgot this side or this side, na, this concept you can remember here. Take the some length, anything 10, 5, 6, whatever. Then 2y by 3 and b by 3. You just put this value. This value is coming 4, this value is coming 2. That means longer distance is here. So this side will be 2b by 3. Shorter distance here, so b by 3. If we take top also, 2h by 3. 2 into 4 into 3 and 4 by 3. So you will see the lesser distance this, upper distance this. So this here, this triangle, what will be the distance? We'll see here. I'm drawing here. Like this will be there now. So this is the 6, this is 3, this is 3. So load already, what is load? 1 by 2 into 6 into 3. So 9 kilonewton. Load will be 9. The load will act to where? So this side will see. From we are taking this side now. So this side now 2, 3 by 3. 2, 3 by 3. This is, suppose this is B. So 2B by 3. 3 gets 2 meter. So from this point E, 2 meter, load will act how much? Load is 9 kilonewton. So I have taken this here. Why this upward? Because this UVL given in the below the beam. So the directions will be upward will be there. So this way we can find the load diagram. Now one more is there, inclined is there. So that also will explain here. So inclined force will be there. See here, like this will be there. This also we have to resolve. This is given 20 degree. This is given 20 degree. This is 30 kilonewton load. So how to resolve the forces? Already you know, 4 directions possible, 3 directions is possible. Horizontal directions, vertical directions and inclined direction. So once horizontal directions, theta will be 0, vertical directions, theta will be 90 degree, and inclined, suppose if there not, theta will be in between 0 to more than 0 theta and less than 90. Inclined force will act greater than 0, less than 90. Suppose 0 will come na horizontal force, 90 will come na vertical force, less than, in between 0 to 90, this is called inclined force. So horizontal force, vertical component will be 0. Vertical forces, horizontal component will be 0. How? So here, suppose we will take here sine 0 and cos 0. Sine 0, 0, cos 0, 1. That means horizontal forces, see this vertical component will sine will be 0. If we will take here also sine 90, 1. So vertical force will be 0. But in this, one component coming 0, here also one component coming 0. But once the inclined force of both component will come, then how to resolve? See the resolve method. Suppose this direction is this way. So draw one same directions like this. With respect to horizontal, draw one line. And draw the mutually perpendicular line. Anywhere in this line. So this is the two resolutions. This is called 30, this angle 20, and this also 20. Near angle always cos component. So 30 sine 30 cos 20. Here 30 sine 20. 30 cos 20, 30 sine 20. We resolve this. Suppose these directions will be like this. Then how to resolve? See the direction. Draw the same direction with respect to horizontal, one horizontal line. And from this mutually perpendicular. Suppose this is F1, this is theta, this is also theta. So this was F1 cos theta. This is also F1 sin theta. This is the way to resolve the inclined forces also, like this direction or this direction. So here they given 30 Newton. So what will be the, this 30 horizontal force how much? 30 cos 20. 30 cos 20 coming 28.191. Vertical 30 sin 20. 30 sin 20 that coming 10.261. 10.261 is coming. This is the load diagram, everything is drawn here. In this load diagram, everything is drawn. So these all are the basic concept you have to first remember. Then only we'll go the three equilibrium equations. Sigma Fh equal to 0, that means total horizontal force equal to 0. Vertical force sigma Fb will be 0, total vertical force will be 0. And moment will take at point A or somewhere. So that will be 0. That is called three equilibrium equations will apply. We'll get the reactions at point A. So these are all the basic concept required. So listen here. Hinge, horizontal and vertical. Horizontal and vertical required. Roller, only vertical. If fixed in horizontal, vertical and moment will be there. Suppose UDL will be there. How to draw the load diagram? Load will act in middle. Load will act into middle because deflections will be in middle. And what is the area? L into B, because rectangular UDL load also known as rectangular load. So W into L load. What is the moment? Load into perpendicular distance. W into L by L into L by 2. So this way. Then triangle. Load will be 1 by 2 B into H. 1 by 2 B into H. Area of the triangle is load. Then where will load will act? Either 2B by 3 or H B by 3. Top if is there 2H by 3. Bottom H by 3. Bottom H by 3. So this way we can calculate the where this load will act. So here 2B by 3. So 2 meter load will acting. We don't worry that na vertical. So this way we can know the load diagram. Now we'll find the reaction forces at point A. Okay, so these are all the basic things you should know. Now we'll apply the equilibrium equation. Sigma Fh equal to 0. In this case, we'll take total leftward force equal to total rightward force. Now we'll see here in this load diagram. HA going this side. HA equal to any reverse force? Yes. 28.191. 28.191 kilonewton. So HA we know now. If this question, suppose they're asking same questions in GATE or some competitive exam, they will give this diagram. They will find the HA. HA na this will be calculated na. HA is the answer. Choice will be there na. This will be the answer. Now again you go the sigma FB equal to 0. That means here we'll take total upward force equal to total downward force. Very simple concept. No negative, no positive. So total upward force, what will be there? VA is going upward. Any upward force is there? Yes. 9 kilonewton going upward plus 9. Then downward force 10. Downward force 6 into 5 because this is UDL load. 6 into 5 is 30 plus 30. Any downward force is there? Yes. At point F 10.261. So 1, 2, 3 downward force, 1 and 2 upward force VA. So this way we can get VA is equal to something. What is the calculations we calculated before itself? VA will get 41.261. 41.261 we got already. 41.261 kilonewton. 2 kilonewtons. Okay, so here we know. Now we'll go to the last equilibrium equations. We'll take moment about A. We'll take moment about A equal to 0. Here what we'll take? Total clockwise is equal to total anti-clockwise. Total clockwise is equal to total anti-clockwise moment. Now we'll see here. Clockwise moment, what is? This is clockwise moment and anti-clockwise. This will come if we take moment about A. This rotating clockwise. So this you write here clockwise. This also will rotate clockwise. This already clockwise. This will go anti-clockwise. This will go anti-clockwise. This is again will come clockwise. Okay. So total clockwise. Clockwise you see here 10 into 2. What is moment? 10 into 2. This is clockwise moment. Then 30 plus 30 into total distance how much? 3, 3, 6, 2, 8. Any clockwise is there? Yes. Plus 10 into 261. 10 into 261. Total distance will be 16. Check it. 2, 3, 5, 8, 10, 13, 14, 15, 16. So total clockwise. Total anti-clockwise, what will be the anti-clockwise here? This is going, one more clockwise moment is 50. So just wait here. Plus already moment is there, no? This is the moment, direct moment. This also clockwise only. If you rotate this, this is coming clockwise only. This given moment 50 equal to total anti-clockwise MA plus this is anti-clockwise, this will come anti-clockwise. 9 into this total distance, 2, 4, 3, 7, 15. So 9 into 15. 9 into 15. So look at here. 10 into 2. 10 into 2 clockwise. 30 into 8. Load into perpendicular distance. 3, 8. Now here one load. Now this going anti-clockwise. 10 into 2.6 total distance. And directly this 50 kilonewton meter moment given clockwise moment. So we wrote. So this way if we calculate, MA will come. MA will come. I will write now. So okay, we write one time here what is 20, 24, 240, 10 into 61 into 16. This is coming 164.176 plus 50 equal to 135 MA. So this calculation is coming 474.176 divided by 135. This is nothing but MA. So MA is we are getting MA will be 339.176 kilonewton meter. This we getting the reaction. So now look here what we'll do here. So they're asking find the reaction at point A. So what is this first answer? HA, this VA, this kilonewton and MA. Now everything we calculated. Now in this like this question, they will give the full problem. Looks very complicated, but they will ask any one things. what is HA, what is BA, or what is MA, or any things they can ask. What is the horizontal force here? What is the vertical force here? Lot of questions they can arise from this question. So if you know these questions, all the basics what we discuss, then you can understand you can solve any type of questions. Okay students, thank you. Watch the video, share the video to your friends so they can get the maximum benefit of this. Okay, thank you.